All right, all right. Hello, hello. Welcome back, everyone. So I am so excited today to welcome everybody here. I don't know if you guys remember, but I was going to take most of August off because my son is here visiting and I wanted to take some time off. So I was trying not to schedule everything, but the Angular team keeps doing all this cool stuff, and I'm just like, what are they doing over there? So I can't help it. So I kept seeing all of these RFCs coming from the Angular team. And if you don't know, RFC means request for comment. So they're actually asking the community for feedback, which I just think is so cool because it makes us feel so important, that we have to ask, talk to them about the roadmap. It's just so exciting. So I reached out to Igor Minar because I've, talked to him before, and he's so nice. And I was just saying, because it's hard to have these discussions sometimes on GitHub across the messages. And it's so much more fun to turn our cameras on and actually discuss these things. So I asked Igor if he would come and hang out with us and talk about these RFCs. And he said, yes, and he's here. So that's what we're doing today. Without further ado. And I just want to say real quick that I'm very excited because I think so far everyone in this call so far is people that we've already known and love and that we've talked to from Angular Nation. So it's just very cozy and warm and welcoming. And I'm so excited to introduce you all to my friend Igor Minar. Igor, how are you doing? Hi, welcome.
I'm good. Thank you so much. Thank you for having us. Thank you for hosting this event. I think it's great that we have a place where we can come and just discuss these things with community members. So thanks for providing the opportunity to us. We really appreciate it.
You're welcome.
Yeah, so I think we have quite a few things to cover, but before we dive into the details, I just want to set two expectations. One is we're just brainstorming here. We are not discussing things that we are committing to. The main purpose of RFC is just to get a community feedback so that we can better understand the possibilities for the future and better understand where, what your needs are, where would you like us to go. So no commitments. Just the discussion. Second one is, I would love this to be informal, and I intentionally didn't prepare much. We just have the RFCs on the GitHub, and I would love to hear from you. So at any moment, if you have questions, something's unclear, please interrupt and ask questions. Raise your hand on Meet or wave or give us a smoke signal. So this should be really about you taking the opportunity to ask questions or ask for clarifications, and not about me telling you what I want to tell you. So with that,
if I can add one thing, because I wanted to mention that we have 2 hours planned today, so we could actually talk through this stuff because there's several things and they're all related, but also I don't want you guys to worry, because if we run out of time, I'm hoping that this will just be the beginning of the conversation and not the entire conversation, because part of my goal here is for you guys to kind of get to know Igor and Alex and a little bit more, and then talk to them more, even beyond today. That's all I want to say.
Yeah, and also, if we don't have to use 2 hours. If we are super efficient, we can wrap up in 1 hour and then just spend 1 hour meditating in a group. That's totally fine with me.
Yeah, hang out.
Cool. So let me present my screen just so that we have the RFC as a point of reference. And there are actually 4 documents that we'll be discussing today.
And while you're doing that, can I also give a shout out to our friend Alex Rickabaugh?
Yes, please. So
hi, Alex.
We have Alex, who's the TL on the Angular framework team with us. And I'm not sure, is there anybody else from the Angular team? Anybody else to join? I don't.
No, we didn't wait that long. Okay. We just threw it up on the calendar, and they're working.
Yes, and it's also kind of early in California. It's 8 o'clock, and usually people start later here. So shout out to Alex for.
And we know that your background is not a green screen because we can hear the birds, and it's so nice.
Yes, it's a real thing. I love trees. But let's talk about RFC, because otherwise I'll just go and hug trees. And you don't want to see that. So let's start with the document that really triggered all of the discussion. And the discussion is about us trying to better understand how people still use the JIT compiler. Now, for those that don't know, Angular actually has 2 kinds of compilers. We have JIT compiler, which means just in time. It's a compiler that runs within the browser. So it's a bunch of JavaScript that is downloaded along with the application, and it compiles the application up in the browser as the application is starting. this is actually the model that AngularJS used as the only way to run. AngularJS had only JIT compiler. With Angular version 2, we introduced AOT compiler, and the whole reason why we wanted to build Angular version 2 was to move away from this JIT compilation to AOT compilation. It turned out to be quite difficult, and there were many use cases where we thought, oh, you will still need to use JIT compiler for this and that. So with Angular version 2, we actually released both the JIT compiler and the AOT compiler. Initially, the JIT compiler was the main compiler because there were still things, there were lots of rough edges around the AOT compilation, and it wasn't quite ready. It was kind of too slow for development mode, and it had various small problems. But over the years, we improved the AOT compiler so that it became the default compiler in version 9, which was 2 years ago, a year and a half, something like that. So as of then, if you're using Angular CLI, you're using AOT compilation unless you did something to tweak your project and not to use the defaults. So with that, we kept on improving the AOT compilation. Actually, in the version, in the most recent version, the language service that powers all of the IDE completion is using the AOT compiler to do all of that. So we kind of like consolidated a lot of that was in the separate language service compiler and the AOT compiler and the JIT compiler into the AOT compiler. And with that, we're just starting to wonder, like, what value does the JIT compiler still bring? Like, is it something that people still actually need, or is it just something that we have here because it's been here forever and we just feel obliged to keep it up? And the challenge for us as people working on Angular is that the more things we need to maintain, the slower we can move. And as you could have seen over the last year or so, we've been trying to quite aggressively remove or deprecate things that are non-essential, just so that we can focus on the things that matter the most, so that we can bring value to the community and people using Angular. And JIT compiler is another thing where we're like, well, this is quite a lot of stuff to maintain. How do people use it? And could we solve these use cases in some other way that could potentially be even better than the JIT compiler? And in exchange, be able to drop the JIT compiler completely. And for those that don't know much about the Angular internals, like maintaining JIT compiler is a non-trivial amount of work, just because there are like so many corner cases where JIT compiler just works differently. So often we need to implement things twice. And what's worse is not just that we need to implement it twice, but the constraints and requirements of JIT compiler and AOT compiler often conflict. And now we just like have to think super hard to figure out like how to do these things so that it works in JIT compiler, it works in AOT compiler, and JIT compiler and AOT compiler don't break each other or don't introduce size regression or memory regression or whatever it is. And it's non-trivial amount of work. So that's our motivation here is kind of selfish. Could we get rid of this thing and in exchange offer some goodies to the community that would make the community happy, and also the team would be happy because we could then start focusing on delivering features and delivering good things. So that's the context for this discussion. The purpose of this RFC is to really just understand what are the current gaps for the AOT compiler that prevents people from using AOT compiler in these use cases. And there are several things that we identified so far. What we know is that unit testing workflows currently rely on this mixed mode where the JIT compilation is used alongside with AOT compilation. And this is probably going to be a surprise because it's not obvious that that's what's happening. But if you're writing your test file or your spec file, that spec file is compiled using JIT compiler. So the testbed APIs internally use the JIT compiler. But as soon as and so basically the component, the testing component that you write in your spec file is compiled with JIT compiler. But the components that this component uses, which is your production component, is actually AOT compiled. And this was one of the big breakthroughs with Ivy, where we made it possible to mix the JIT compiled and AOT compiled code together, because previously, like, everything had to be either JIT compiled or everything had to be AOT compiled. With Ivy as of version 9, we can have this mix mode, which allows us to leverage things that have been already compiled for production mode and use it in tests without having to recompile it. So unit testing workflows is one of these places where we know that JIT compiler is still used. The second one is use cases that rely on dynamically generating templates. This is usually like CMS systems or data-driven systems where you have a database that contains lots of information, and based on that information, you actually generate the UI on the fly in the browser. And to do that, you typically, and I cringe when I see this happening, people just concatenate strings and then feed that string into the JIT compiler, compile it in the browser, and then render UI using this JIT compiled component. There are two challenges with this approach, which is you have to download the whole JIT compiler to the browser to be able to do this. Of course, you can lazy load these parts of the UI if they're not in the critical path of like rendering the initial screen. But still, you're downloading a lot of JavaScript into the browser just to be able to have this feature. Additionally, there are security implications. The JIT compiler, if it compiles user-controlled strings or user-controlled input, the user could actually introduce a cross-site scripting vulnerability into your application because they fully own what will be, like, they control the code generation. For this reason, the security team at Google actually banned the JIT compiler to be used in production. So no production systems at Google can use JIT compiler because it's just not safe to do so. There are other problems with JIT compilation where like some things just work slightly differently and it can result in weird inconsistencies. But nevertheless, people still use JIT compiler for this use case. The next one is the original version of the upgrade library from AngularJS to Angular actually relied on the JIT compiler. Since then, we introduced the static version, what we call static. So there's @angular/upgrade/static. That is different version of the upgrade library that actually uses AOT compilation and doesn't rely on the JIT compiler. And because of this, we actually deprecated this original version of the dynamic upgrade. So we don't think anybody's using it unless it's some super old application that started migration but never finished it. In any case, we don't think this is a big deal. The last one that actually came up in the discussion on the RFC already through community feedback is that in some cases, people's code bases are so big that the AOT compiler is still not fast enough for interactive development workflows. And in this case, these teams have found that using JIT compiler actually gives them faster at the refresh cycle than AOT compiler. This is not what we are pleased to hear, and we would actually love to know more about these use cases and better understand what is it about this code base that makes it so big that that the AOT compilation takes a long time. Because we've done a lot to optimize the AOT compiler. We expect it to be fast.
Igor,
but
can I interrupt you there a little bit?
Yeah, please go.
What I have seen in those large code bases is that actually the TypeScript type checking takes a really long time, which we are going over in one of the next RFCs, I think.
Yes.
I can confirm that, yes.
Okay, cool. So I'm not going to spend too much on this because there are actually two separate documents that discuss ways how we could optimize the build. But this was one of the things that people mentioned, that they use JIT compiler because it just makes the interactive development workflows faster. And the last part of the RFC just describes what would be the benefits of standardizing on the AOT compilation. The first one is consistency and predictability. Having one compiler is always better than having two, because there are corner cases and weird things where things don't quite work the same way, and then you might end up with a code base that compiles only with JIT or only with AOT, and can be a lot of headache. The second one is fewer runtime and performance security pitfalls. As I mentioned, downloading the compiler into the browser and running it in the browser is insecure and slow. The next one is, we do recognize that the use case for dynamically generating views based on some dynamic data stored in a database is a real use case. And our offering here is, what if we gave you another API to construct these dynamic views at runtime using this proposed view composition API? And we'll go into details on that one. And the last one, the last benefit of dropping this is that we could actually focus on improving the speed of the AOT compiler further. And there are at least two proposals. There are other ideas that we have how to make it faster. And we'll go into the out-of-band type checking. As you mentioned, type checking is one of the problematic parts of compilation and time-consuming parts of compilation. And the second one is actually move away from this very coarse-grained compilation model that gives us only limited opportunities for parallelization to more fine-grained and parallelizable localized compilation. We'll go into detail on that. And that's essentially it. That's the proposal. Help us understand how you use JIT, and let's explore together opportunities to fill in the gaps that still keep you on JIT, in exchange for us to drop JIT and for you to benefit from new features. Martin, go ahead.
I didn't write it down in that RFC because it never saw the day of light in a public way. We have Electron app where we can import a component library, like for example material, and then drag and drop designs and get out a fully fledged code where we can start working on. So this is for our designers. They can take the component library, make first drafts with layers and so on and so forth, press the export button, and we get out code. This works perfectly with React. We have seen it working with Vue really good. I made an attempt to use JIT here because of obvious reasons, because we obviously imported, we needed to import stuff on the fly, so the component library on the fly and compile it on the fly in the Electron app. And I still feel a lot of urge around me from clients from within our company to make this happen. We just stopped it at one point because we didn't think it is feasible with JIT compiler, because we wanted to go away from JIT compiler. But that would be also something, especially when it comes to dynamically creating views. Not well, that was a pun that was not intended. Dynamically creating applications based on component libraries, where we would use the JIT compiler a lot.
And you use the JIT compiler just for like the preview mode, or you use
for
it
the
in
preview
the final
mode
product?
For the preview mode. So the result of that would have been the actual Angular code, like you would have written it yourself. So it's a lot. You have an app component, and then the template would have been written as a result of that, and then you can take that into a regular project, do whatever you want to do to make it really better, and then use that as a production thing. So it's a pre-step we use it as a pre-step in our design to production flow. It's like, you can think about it a little bit like an app builder. If you know the app builder that Apple had in the past, a little bit like that, but without all the inputs and outputs, more of a visual app builder.
Are you by any chance allowed to demo this? Sounds super interesting.
I, by any chance, can give you the repo that is a little bit older. It works just with React on the official version. And I just realized that the link is not working anymore for the website.
Yeah.
So give us our money back.
Yes. No. But this is our official version that we provided some time.
So this is interesting. I have several ideas. One is, I see how JIT mode can work here, but again, there's a potential that your preview might work with the JIT mode, but once you actually generate the application, it will work slightly differently because there are slight differences between JIT and AOT, and they're just
so the version I wrote in the past worked, but it had some wackiness, just like you described it.
Yeah, I'm not surprised to hear that. So
I'm also guessing your previous version was old enough to be using the View Engine JIT mode and not the Ivy JIT mode.
Yes, exactly.
There were even more significant differences between the two back then.
Yes. So that's why we stopped taking, I stopped taking time to get this to work with Angular. So currently it's just working with Vue and React, unfortunately.
Yeah. So several things come to my mind. One is that you could feed all of the input into the AOT compiler that runs behind the scenes. And this is essentially how StackBlitz works. They use the AOT compiler to run the previews, so it's feasible. It might be too heavyweight for some use cases. I don't know how much code you generate, but that's one option. The other option is, one of the things that I've been thinking about for quite a while is, instead of JIT compiler, could we actually move the current compiler into a service worker and compile the application on the fly, still in the browser, but in a different context, and use the proper AOT pipeline all the way through, so that you get the consistency, you get the security, and because it's in a service worker, you don't pay the performance penalty unless you're trying to render things that will be like the initial view to bootstrap the application.
That would be awesome.
It's a stretch. This is not something that we're currently like. I've been thinking about it. Maybe I discussed it with a few people, but we don't have any plans to execute on this right now.
Honestly, what I saw as one of the biggest benefits in that case scenario, and we had some scenarios like that in the last years over and over again, would be what you mentioned in one of the last topics, or the one shortly before, the imperative view and template composition. That looks a little bit like incremental DOM with a higher abstraction layer. Something like that would work really well as a replacement here for us.
So that's the third option that I was going to mention, which is one of the proposals, this imperative view composition API, which could be used in this case. But it sounds like at the end of the day, you actually want to produce proper Angular application. In which case, I suggest you. The view composition is not meant for like this generated applications. It's meant for things that need to be, for views that need to be created on the fly, primarily because anytime you move into this more dynamic mode, there's some trade-off. There's usually performance penalty you need to pay. Things are not as optimized. Maybe the bundle size, payload size will be slightly bigger. But here's an idea that I had for the view composition API, which is I would love to build a prototype of it by building a small compiler that takes the current Angular template, parses it out, and creates code. Actually, the opposite is true. So take the view composition API that I just sketched out, generate a string out of it, and compile that using the current JIT compiler, just to show like, oh, you can actually create all of these views and it's just going to work. But you could do the opposite for your application, where you could actually generate the view composition API calls and create your preview using that. And once you're done with the preview, you convert the dynamic composition API calls into the Angular template. So you convert it from that to a string.
That would be probably a little bit the way I would like to go. Yes.
Yeah. So in theory, all of this is possible. Of course, in practice, everything is harder because the reasons. Real life gets in the way. But yeah, it's a possibility.
Martin, as you are using an Electron app, you have full access to the AOT compiler anyway. So you can just on the fly compile the library and load whatever you need there.
It was meant to be it was meant to be a web app in the end. So the Electron app was always
okay. Yeah, then and actually Igor robbed me from a question I had, like, hey, why can't we use the AOT compiler in the worker? So that will be a new RFC, I suppose.
You can write it.
Yeah, I'm really looking forward to that, because that would make all of the use cases that now need the JIT available to all the users in a proper way, instead of using the JIT way, more proper way. Because shipping strings to the main thread in the browser, I really don't like that idea from a security high point.
Oh yeah. Kai, were you gonna ask?
Yeah, I don't know if you got your idea correctly. Have you suggested to pass a template, an Angular template, and create instructions out of it? Or did I get this right?
So I actually said several things. So one of the things, and maybe it would actually make sense to go over the imperative composition API so that everybody has the right context for this, and then we can talk about the options of these options that you mentioned.
Yeah, that's fine.
Might make more sense. Aristides, did you have a question?
Aristides from Bacchus.
Yeah. Hi, Igor. Very nice to meet you.
Call him Aris.
Hi.
Yeah.
Wow.
I just wanted to talk about the use case for one of the companies that I mentor. They are creating a menu dynamically from their API. So it is a data-driven application, and each item of the menu, when you click it, it loads a different component. Now, the data that come from the server have the selector of which component belongs to which menu item. So what they do, they're actually using the compiler to compile the component given the selector name and then load the component.
Mm-hmm.
So it would be great if there was a method to load a component dynamically using its selector. And that would solve all the problems.
By the selector? Or
yeah. By the selector, yeah.
But how do we know what code to load? Maybe I don't understand.
Yeah, the components are compiled. They are compiled during runtime, but which component is loaded from which menu item, they don't know it beforehand because it is from the server. The server says that if you want to, that the menu item A will trigger the component, the CMPA selector. But the component is there. It is compiled already, but they don't have it runtime in the Angular code. They don't have this relationship. Which menu item triggers which component?
Yeah. So I think Sanders suggested that you have a lookup table where you can map
Yeah,
selectors.
yeah. Mm-hmm.
I
was just wondering if an approach for if we load a component using the selector, I think I don't know. It sounds simple to me. I know it's not, but you know.
The problem, Aris, is that you only know the selector after the component is compiled. So loading the component by its selector is a little bit hard, and you really need a lookup table for that. And if you have a lookup table, you can just import, use the normal import to load the component dynamically, which is, I think you have even talked about this before.
Yeah.
Yeah.
Cool.
Maybe if we look at the dynamic composition API, we can discuss your use case in detail, because one of the things it shows is that you can take a component that you don't know at the time when you're building your application and add it to your application dynamically.
Mm-hmm. Okay, thanks.
Okay, so let's quickly go over this proposal. And this proposal, the dynamic composition API, addresses primarily the use case where the view, the structure of the view, is not known at the time when you as a developer are writing the application. So imagine use cases where you fetch user preferences from the database, and you can have, let's say, a dashboard that contains weather widget and a stock ticker and some other information, and users can choose and pick which ones they want. Additionally, you can imagine a third-party ecosystem of these plugins that are just published to some kind of repository, and users can choose these additional widgets to be part of the dashboard. So you as a developer just have no idea what widgets developers want to use, and secondly, what widgets are even available, because third-party developers can upload them to some repository. There are other use cases, things like dynamically generated forms. So often you have sophisticated tax or insurance forms that have fields specific to country or particular circumstances of the user, and you don't. It would be too difficult to create a static template, even if it used all the ifs, ng ifs, and ng switches. It would still be too difficult to do so. You would want even more dynamicity than that. So the idea is essentially that we would we would expose a new set of APIs. This is just a sketch. I'm not attached to any of these APIs. I just need to write down some kind of proposal so that we have something to discuss. But the shape of the API might be completely different by the time this is actually seriously explored. But imagine that we had core compose. And from there, you could import things like create view, HTML, component, directive, text, binding, and text. And in the using these APIs, what you could do is you could construct a view. So you called create view, and now you need to provide some kind of tree data structure that describes the view. So you can have some static parts without any kind of binding. which you would create using this HTML helper. You can have a component. So you would say, oh, my view after this HTML actually brings in a component, and it's this component. And here it's explicitly defined, but you can imagine that this is just a variable that comes from somewhere. You don't know what it is, but it's some kind of component. And this component has a projection, which is the nested thing in the tag that can be, again, just static text that also contains a binding. So this would be like username. You can actually use JavaScript expressions here, which is something you cannot use in Angular templates. So you can have conditionally, you can add additional text. In this case, I just use silly math random, just say, oh, sometimes this text will be here and other times it won't. But you can imagine that there's another more serious condition that guards this section of the view. You can add additional component, but this time, this component also has a directive. In this case, I used router link. So this kind of template would be roughly translated something like this. But again, keep in mind that this is all imperative code. So you could add more expressions to it. It could be much more dynamic than Angular template. And lastly, of course, you can create structural directives and templates. So essentially, we would provide all these helpers that would be as expressive or close to as expressive as the current template. There might be some restrictions where some things might be just too crazy to expose in this way. Or maybe we would be just a little conservative initially to just expose the most commonly needed subset and eventually expand it. But you can imagine that any kind of template that we have today defined in an Angular template as a string or HTML code could be expressed using this dynamic API with much more flexibility. And the result of this create a view function call could then be inserted into view container ref, and you can basically append it. So you could have a fully static AOT compiled application which has embedded view or parts of the displayed view be created in this very dynamic way based on the data from the database, based on the data from some API calls, and incorporated into the existing view. This would all be stitched together with a DI and change detection. All the bindings, everything would work the way you expect it to work. And you could use the full power of directives, components, everything we have in Angular today. Pipes, of course, and so on. Again, this API is just the placeholder. I'm not attached to it. The reason why I chose this API, and I think I described it, I would like to have something declarative so that it's easy to read, and something that is not monolithic. So often people create these kind of APIs for building AST trees as a fluent API, like RxJS version 5 was, where you can just chain things. But as soon as you start chaining things, that means that you need to bring in the whole. If you import the API, you're bringing everything, even if you don't use certain helper functions. And this is one thing that we need to be careful about, because it could just bring in too much stuff into existing applications and explode the payload size. So having these individual functions actually allows us to support tree shaking and optimizations. But again, like, this is just a placeholder. We can discuss what the API should look like. Questions?
Yeah.
Go ahead.
Well, actually, I'm not in the queue. I think it should be fair that people in the queue go first.
Okay, Martin.
I have 3 questions / 2. First of all, this is from all the new RFCs. This is the most amazing one for me personally. I have first question. Do you think it would also be feasible and useful to expose some way to have the what is it called, the shady DOM styles CSS inclusion? I'm not sure how to name it. You know the styles, style tags that you add in the head that have the dynamically created ng host stuff in there in the same way.
Probably. I haven't thought about it that far, but I think it would be hard not to do it and keep the system useful in real world cases. So yes, that would be part of it. But as I said, this is just a rough idea. Lots of details need to be sorted out, and this is a good point.
The second one, and I wrote that somewhere in that thread as well, is I think as much as I like the more readable approach of this, I think some kind of tooling where you can create a standard Angular component like you would have written it in a normal way, pass it to the tooling, and it spits out this declarative version of the same component as a starting point to iterate on it, I think would be really great.
Right. So that was the idea that I mentioned in the first part of the discussion, where in order to prototype this, the approach I would like to explore is creating this simple function, say HTML component and whatnot, that would spit out a string that is then fed into the JIT compiler. And I know that it's ironic that I'm trying to get rid of the JIT compiler, but while it's still around, let's just put it to use. And we could prototype and get the feel of, how much flexibility would this give us? Would this be this be useful in the practical scenarios that we are trying to address? And what are the constraints and limitations of this? So yeah, that is definitely one of the things we can explore.
And the third one is I wrote, 2 years ago, some proof of concept compiler for templates that look a little bit like Angular without the directives and all that stuff, with all the interpolation and so on, to incremental DOM. So it compiles the template to incremental DOM instructions. Would that be helpful in some way? Should I share it somewhere? Should I make it public on GitHub to have maybe a starting point on thoughts? Would that help anyway?
My general preference is that people should share things, but not have expectations, because it's great to explore many different approaches, and incremental DOM is something we looked into quite a bit, especially when we were starting with Ivy. Like, one of the ideas was like maybe Ivy could sit on top of incremental DOM, but then we realized that first of all, it would be a big change, big departure from the current change detection mechanism that we have in Angular, which would probably make it impossible for us to bring the existing ecosystem onto Ivy. And secondly, there's still, and this came up later, especially as Svelte came out and they started showing up like, we don't need silly DOM or virtual DOM to be performant. Like, there's an argument to be made that incremental DOM and virtual DOM is just the extra overhead that is not necessary. And especially in virtual DOM, as it is used in React, it has big pitfalls and big problems that are not obvious. And in many cases, change detection or even incremental DOM. Like, if I had to choose between virtual DOM and incremental DOM and just change detection in Angular, I would go for either incremental DOM or change detection that we have in Angular compared to the virtual DOM. So yes, short answer is you can share it. We can take a look. But I think going from where Angular is today to incremental DOM is a big jump, and I'm not sure if it would be realistic.
What was more like inspirational, not going to incremental DOM. I totally understand why incremental DOM is out.
Yeah, cool. Good tree.
Yeah, thank you. So I want to go back to your little comment about the API and Fluent APIs. I'm a big fan of Fluent APIs. But you mentioned that having things like this may increase the build times because you would have to import a lot of things right away, even though they might not be used. So my initial thoughts there, questions, more like questions to you because I want to learn more. Since everything is AOT compiled and it's not really brought to the browser, I understand the build times are going to be increased, but that doesn't necessarily mean that runtime performance is going to be affected in any way. So that's my first kind of clarification question. And then second, how does this all fit with your other proposal to, what is this proposal called? The transition Angular from the whole program compilation to localized compilation.
Yeah, good questions. Thank you. I'll address the second one first. The two proposals are actually unrelated as far as I can tell. You can transition Angular to localized compilation without doing this imperative composition API, or you can also do the composition API without transition Angular. Completely independent and there is no significant connection between the two. Let's talk about the first one, which is...
Before we move on to the first one, wouldn't the work that you're proposing in this RFC help with the build times?
No.
Because everything is localized? No?
No, because, and I think this is where, if I understand you correctly, I think there's a disconnect between how you're thinking about what I'm proposing and what I'm trying to propose. This code, this composition API, would not be AOT compiled. This is just pure TypeScript code that sits there. The compiler doesn't do anything with it, at least in the initial phase. We could talk about optimizations where like there could be crazy things that the compiler could eventually do with this, like unwrap the, because the proposal as it stands today, and I'm not saying this is how it's going to be, if it will be implemented, just suggests that all these helpers are essentially wrappers around existing low-level IB instructions. This low-level API is unstable. We keep on changing it even in patch releases, so it's not something we want to expose, and it's not even ergonomic, so it's not something you want to use on your own. But we could build this higher-level abstraction that is more constrained and more stable that we would be comfortable exposing as a public API. And what you can imagine is that eventually, if this takes off and we see that this is less performant because it's this additional layer on top of instructions, you can imagine that with AOT compilation, and this is where like even I'm just like hand waving, the AOT compiler could unwrap some of these helpers and actually like replace them with the low-level instructions to achieve better performance. But that's like so far off, like we don't even have the essential foundation to even start thinking about how to optimize this. So, but the main thing is that you should think about this as a pure TypeScript functions that are not AOT compiled, that execute at runtime and just wrap the low-level IV instructions.
Got it. So that actually would then totally affect the runtime performance.
Yes. So, and that's one of the trade-offs that I mentioned. I do expect that views created in this way will perform not as efficiently as fully AOT compiled template. We could get closer to fully AOT compiled template using additional advanced optimizations, but in the initial step, we probably wouldn't do that. And in my experience, it wouldn't be such a big deal because in most of the cases where you need all of this dynamicity, the performance penalty for this dynamicity is inconsequential. It's not significant. User experience would not be significantly impacted.
Got it. Makes sense. Thank you.
But great questions. Do we have other questions? Kai, go ahead.
Yes, I can still cannot get rid of my last question. In the last comment of this issue, I mentioned that if you use Storybook, you can write story files and just write down a template. And this template, how is it solved this nowadays, is that it's generated during runtime, the component of it, and the module and the dependencies of it and stuff like that. If I now would parse the template and create the instructions myself, I really wonder if it is actually realistic to achieve this and make this production ready. What do you think? I have an example at the bottom, and if you want to see it. So
at the bottom of
this issue, yes.
Yes. Well, let me help. Please help me find
this one, exactly, the lower one, where I can write a story that has a template, and you can also pass in properties. And now we would need some kind of generator that takes this template and translates it to the instructions you mentioned, because you said directly taking this template. Sander, I think Sander proposed this in one of the first comments. Directly taking this template and just throw it in would again kind of is the JIT way.
Yeah. So 2 ideas, and maybe Alex can also chime in because I'm sure he has thoughts on this one. One is this use case is very similar to the unit tests and the testbed APIs. And my current thinking about that is that maybe we could teach the AOT compiler how to recognize some of these embedded components within test cases and compile them as if they were proper components. I don't know if this is fully feasible. Alex can chime in and point out any kind of big flaws in this thinking, but I would love us to be able to just take the testbed API as it is today with all of the tests that are out there and AOT compile them. Alex, thoughts?
Oh, I was actually thinking of something in the opposite direction, which is recognizing the kind of use cases or patterns in tests today where you have a component that is dynamically compiling its template and rewriting that into the view composition API.
So yeah, that's exactly the second approach, which is that we kind of discussed already with Martin and his use case, where it is feasible. So there are 2 prototypes we could build for this composition API. One is that it takes the composition API and spits out string that is compiled by the current JIT compiler to just show like, oh, actually you can use the composition API to create views. But you can go the other way. Also, you can take, turtles all the way down, I guess. You can take the string, parse it, create the composition API, which actually is the prototype that we mentioned just before, which turns it back to strings, which is compiled by the JIT compiler, which is then rendered. So yes, you can make the whole loop.
I feel like the second approach would give you something later out, namely you take a string, compile it, and get out something that you can start on working. So it could help improving this tooling later.
Yeah.
There are some challenges with that, I think, but it really depends on like the specifics of the view composition API that we build. It's hard to get to a full template string out of that, mainly because your interface to bindings is really dynamic. So you're just passing in a closure that has some like expression that's being evaluated. So like at runtime, you don't really know what the text of that expression is to put into a template string. That seems like a problem to me.
Yeah. All these things are easy in theory, and then you start like poking around and it just all falls apart. So yeah, more thinking needs to be done. But
yeah,
I think like the thing that we're trying to figure out right now is like, is there enough interest in the community in this feature for us to invest our attention into developing these ideas further and creating more prototypes and stuff like that, because there's just so much for us to potentially work on, and sometimes it can be overwhelming just to pick the right things to work on. So the goal here is just to see, is there interest in this, and should we be spending our brain cycles on trying to solve these problems and develop the solutions and develop them more. Thanks, Martin. Cool. One more thing I wanted to mention with regards to this proposal is that in the title, I say that it's a view and template composition API, but really what we discussed mostly just the view cases where you generate the view. And I understand that for many, the distinction between template and view might be kind of blurred. In Angular, template is like the prototype of the object that we create, which is the view. So the proposal as it stands, it's primarily focused on creating the instances that are then attached to the view. But you can imagine the same kind of approach being used to actually create templates, which is like, it's additional layer of indirection. It can be harder to reason about them and build them, because you need to pass around context and what do you bind the template to. But it would be even more powerful API at the cost of complexity. And it would be an API that would not have, most likely would not have any kind of runtime performance penalty compared to AOT compiled code. This is a stretch. I didn't want to go into details on that in the RFC. I just mentioned that this is like one of the open questions to explore. I don't know if that's something anybody would like to discuss, or if we should just move on and go to the other proposals.
I really like that idea, but you're shifting to a new level, which takes some complexity. Right. I think we should move on to the next ones. I'm going to.
Can you write that down in some way, somewhere, so one like me who didn't could follow you right now can reason about it?
Alex, could you try to reword it, because I'm running out of words how to simplify the explanation of this.
Use small words, y'all.
I know.
You guys have been thinking about this for a while. I also like the idea of like making it like an optional spike. Is there any way that you could like build a prototype for us to play with without actually committing to it? That we could break it?
We're not committing to anything at this point.
Perhaps I can reward it, and then you can see if I got it all wrong or not. Okay. Basically, this view thing puts out like instances, so it turns like out a DOM element directly. What Igor was talking about was actually a layer on top of that puts out components like a class, the class definition instead of the instance. Does it make sense to you?
Exactly.
Thank you, Sanders.
You're welcome.
Right.
Is it class definition plus the template?
Yes.
Yes.
So this API, the create view, returns. You can think of it if you make a comparison to JavaScript or TypeScript. This API returns an object instance. The template composition API. So if we could have a template composition API, which would be probably create template, and that would return what in JavaScript is a class or a prototype function. So it's like one level before, and it would be the thing that then you use to instantiate views using the existing APIs that we already have, API that Angular has to create views from templates.
Yeah, so creating the template is very similar to what you would do with the JIT compiler today, where you would kind of dynamically create a component class that has a template that was constructed from string concatenation.
and it would work for Martin's use case where you can create like a template where you can feed in every one of your material components. You just wrap them in one of those templates and you spit out an instance for every different component. It's not entirely, but...
So this would be useful in cases where the dynamically composed UI is repeatedly recreated. So if you, like in Martin's case, I believe that you would just create it once as a preview and that's it. But imagine that
it's interactive.
And that's fine. So that's fine, but interactive after you update, so you have to reconstruct it.
So no, it uses a lot of drag and drop, and so what Sander said sounded a little bit more like what we actually tried there.
Yeah,
wrapping the actual components, and they have interactions inside the web app where you can drag and drop them, and then in the back you have some information about how the DOM or the DOM looks like, and it renders the stuff.
But do you ever like drag and drop things to a container and then use that container to stamp it out 10 times in a for loop, in a list or repeater or table?
That one we did not do, no.
So this is where the template composition API would be useful, because anytime you have this encapsulated unit of view that you need to stamp out many times in a table, in a list, in a for loop, that's when you would get the performance benefits of the template composition API. If you are just creating the view just once and change something and need to recreate it again, then the view composition API is sufficient. You won't get any benefits from template composition API.
Gotcha.
Cool. Can we move on to the next topic, or do we have other questions?
I think we can move on.
Okay.
I just want to say, sometimes I ask questions because I think things are unclear, not because I don't already know the answer or understand.
Sander knows everything.
Sander,
we know you know.
I don't know everything.
We know that you know almost everything. So
he probably knows the answer to all of this. He's just waiting to see if Igor can figure it out without help.
Evil Sander, evil Sander.
Yeah, no. I will question him afterwards. He gets a test.
Okay. Oh, now I'm stressed out. The pressure is on. Okay, so as I mentioned in the original proposal for the JIT mode, and exploring potential removal of JIT mode, I don't have the tombstone ready yet. It's not a done deal. So we're just exploring. One of the things that came up was that the builds are slow, and somebody, I forget who, I'm sorry, already mentioned this, like, yes, AOT compilation is not fast enough. So we've done a ton of work to make AOT compilation and just builds in general faster in Angular CLI, and there's more that we can do, but we are hitting limits, and the limits come down to just the current way of doing things and current constraints we place on the system. And one of the current constraints is that type checking always happens in the critical path before we execute any unit tests, before we render we re-render development server, we refresh the development server, and we know that the type checking cost can be substantial in large code bases. So one of the proposals that I threw out there as a potential solution, or part of the solution, is what if we move the type checking to be out of band with respect to this interactive dev flows? What it means is that just like use Angular today, you would start ng-serve or ng-test-watch. That would start the server, either test server or dev server. And anytime you make a change in the editor, Angular would process the change and prioritize generation of JavaScript and getting the tests and the dev server refreshed over type checking. The type checking would still happen, but it would happen out of band asynchronously, not in a non-blocking way. And this would allow us to reduce the latency that you have in the edit refresh cycle. Additionally, there's this really nice benefit, and this is something that it's just something that I like, and maybe other people don't like it. Often when I'm asked to solve some problem, or if I'm trying to solve some problem, I want to explore and I want to experiment. I want to break things before I get them right, just because I can think of 7 different approaches how this could be solved, but only probably 1 or 2 will be viable. I don't know which one of those 7 are viable, so I just want to explore them quickly. In order to explore these 7 approaches today, with every change, I need to make sure that the type system is happy and that the type checker is happy. I often end up just putting any's all over the place or unknowns as types just so that I get unblocked. Because what I really want to see is I just want to see some results in the browser from my dev server to see that things render in the expected way, or I want to see some tests partially pass, or I want to see some console logs that just tell me that, oh, I'm on the right track here. I know that things are broken still, and this is not something I want to commit yet, but I just want to get this faster feedback from the system to know whether I'm on the right track or not. And once I feel like, oh, this is the path that I want to go down, then I go and fix up the types and make sure that everything aligns just right. And maybe at that point I will realize, oh, actually this is a bigger problem. I need to refactor this API and that API. But I know that it's still worth doing, and I should continue going down that path. Some of the concerns that people have raised with this out-of-band type checking is that, well, this is not how Angular works today. Like today, if I make a mistake, Angular slaps me in the face and tells me like, don't do this. This is not right. Which is good for some people, but not good for everybody. One of the things that has changed since we started with type checking and AOT compilation is that the Ide support is so much better than it used to be. With Angular version 11, we have new language service that is super fast and as rich as the compiler itself, because actually the compiler itself is running as a language service. So you get all the feedback in your IDE very quickly, and you don't need to type check things in the terminal on the command line. So the risk of you not knowing that there is a type checking issue is decreased. Additionally, sometimes it's this in some cases this type checking errors are crucial and you want to know about them because maybe you didn't realize that you made a type checking issue, and it's affecting your experiment or tests in an unexpected way. So this out of band type checking would not completely mute the type checking feedback. It would just deliver it asynchronously. So you would still see the type checking issues in the console. Maybe we would give you feedback like, oh, tests are passing, but the type checking is still pending. And eventually the type checking would come back, oh, type checking is good, or oh, type checking found issues. Similarly, in the dev server, you can imagine a UI where we would show the type checking errors as overlaid in some non-obnoxious way in the UI of the application. So your application would render or partially render because you're exploring, and we would have just a pop-up telling you, hey, warning, Angular CLI detected type checking issues, just so that you know. We are not going to prevent you from rendering the application and poking around, but just so you know, there are type checking issues. So we would still give you the feedback. It would just be out of band. It would be provided in an unobtrusive way. And the benefits are that we would enable you to explore things without the type checking blocking the exploration, and things would be faster because the type checking happens in parallel and out of the end of the critical path. And now I'll shut up and I'll turn it over to you.
I feel like Sandra's going to start, because Sandra always starts.
I'm a fan. I really would love to have this out-of-band type checking, because you're not the only one where types get in the way when you quickly want to iterate on something or just.
Angular slaps me in the face too. No, I'm just kidding.
Yeah, sometimes you just want to try a brain fart, and it's not like serious code. You just want to quickly try something, and then you spend like half an hour on fixing the types, because otherwise you cannot even try the thing you wanted to try, which annoys the hell out of me every now and then. I get the types, I know where they are, but sometimes I just wish I could turn them off with one switch, iterate on something, and then turn it back on when it is ready for serious work.
Yeah. I see Martin's asking some questions in chat, but just quickly, one more thing that I forgot to mention is that, this idea of out-of-band type checking is not new. This is not something that I came up with. I'm just the messenger proposing this to the Angular community. There's a lot of prior art in the web ecosystem. If you look at systems like Dino, which is the potential replacement for Node, we'll see what happens. I'm a big fan. It supports TypeScript as the input language, so you don't need to transpile TypeScript into JavaScript to get it running. And you still have the execution engine, just like Node, that runs this code, but it doesn't give you the type checking feedback. So it essentially just ignores the types and runs the JavaScript without you having to transpile it. And it's up to you to have out-of-band type checking that does it, that does the type checking for you. There are additional systems like SWC and ESBuild, which are modern, very highly parallelizable transpilers, JavaScript transpilers, bundlers, optimizers, that also accept TypeScript as an input, but they don't bother with type checking. Type checking is the business of Microsoft's TypeScript compiler. If you want to get type checking feedback, you use that. If you want to have quick turnaround, if you want to have quick bundling and optimizations, you can use SWC and ESBuild. Vite is Evan use dev server that has a bundler which actually uses ESBuild under the hood. Also supports TypeScript as an input language, but doesn't give you type checking feedback directly. It uses TypeScript compiler for that, and I believe similarly to how I proposed that the type checking would be injected into the dev server output in the browser, you also get some notification about type checks. I haven't used Vite too much yet, but I believe that's how it works from the demos that I've seen.
I used Vite for a quick trial with Angular, and it worked wonderfully well. You had to compile everything with ngc before you can load it, so you're still compiling everything before, so you're losing a lot of the things, but for that the next proposal will be
that's
really useful.
That's where the next proposal comes in. Yeah, and there are few more things. TS Node allows you to run TypeScript in Node without type checking. Bazel is a build system that we use heavily at Angular, and entire Google runs on Blaze, which is the internal version of Bazel. And there, originally, the type checking was blocking in a critical path. But what we see more and more especially in the external web ecosystem, is that type checking is being converted to just a test. Essentially, you can think of it as a very powerful linter rather than something that is in critical path. And last thing I mentioned first, Babel supports TypeScript as an input language, just to make the interop between TypeScript and JavaScript simpler, but it doesn't bother with type checking. So it's again just how to process the input, ignore the types, leave the type checking to the TypeScript compiler, and just generate JavaScript that can run in the browser. So all in all, there's a lot of precedence for this in the community, and I like this kind of thinking, and I think the Angular community would benefit greatly from it. Let's go to questions. Martin, do you want to just ask the questions out loud?
This was meant more as a general question, because biggest thing. So my question is, terminal output.
Is it just me, or is Martin cutting out?
Martin's cutting out.
Oh.
No worries.
I'm just going to read out. Here. Sorry. What is your thought on opening a second browser window in dev mode that gives results of type checking instead of writing in the terminal? One browser window is better than two. If we could just inject the feedback directly into either the Karma page or the ngserve page with the application, in a way that doesn't mess with the application, of course. Like, it needs to be isolated from your style sheets and code, then I think that would be better. But something that could be explored is I just find it, having two windows is always more trouble than having just one, if it just results in better developer experience.
And you would see those compilation errors in terminal anyway, right?
Yeah, assuming that you have the terminal open.
Right.
We also need to be mindful that not everybody is fortunate enough to have large displays with like lots of terminals and windows open next to each other. Like many people have smaller screens, or when I work, my private laptop is just a small screen, so there's only so much I can put on the screen. So keeping that in mind might be a good thing, and more inclusive of people that are not as fortunate.
But also, where you would definitely catch this error is during the production build. Absolutely. Because that would actually block it. So it's Absolutely. Not like you're going to get some bugs through in the production.
Absolutely. So the CI system would still execute the type checking. There is a question whether it should be blocking or non-blocking there, because there's a trade-off. Like, sometimes if the type checking is taking 5 minutes, you would rather just run it in parallel with your test runs. But also, if there's a severe type checking issue, you don't want to run your unit test, because if your unit tests take 45 minutes as opposed to 10 seconds of type checking, then you might be wasting a lot of time on CI. So I think that this setting should be configurable, and teams might want to be able to like flip between blocking, non-blocking, and maybe even off in some cases. Now, I don't know why you would want it off, but maybe in some cases.
Yeah, I really see this as, like, currently we run type checking, code generation, and tests in series, right? So your type checking has to finish before we generate any JavaScript, and then your JavaScript generation finishes before we start your tests, or start up your dev server or whatever you're doing. And you can imagine that there are different ways of doing this that take advantage of the fact that you have a pretty powerful processor that can do multiple things. So you would run your type checking at the same time as you're generating JavaScript code. And then maybe you wait for both of those to finish before you start the tests, or maybe you start the tests and then cancel the tests if the type checking comes back with errors. There's different ways of orchestrating these tasks that just optimize the time we're spending doing all of it. But I think doing them in series is probably the least efficient solution out there.
I love this, Kai. ng build only type checking, don't actually build it. Thanks. Yeah, leave that in the GitHub comments.
And use exactly that flag, please.
Yes, I love the flag specifically, Kai. Can we get that in the next version? Only type checking, don't actually build it. Thanks. Nice. Oh, and we also need Aristides's. What was that? What were we saying? Human readable IV. So we would do ng serve -- HRI. Yeah. Alex. Oh, we're getting a little crazy here.
Keep your typos to yourself.
Okay, thanks. Bye.
but honestly,
no
I think
types.
that
We can write JavaScript. Yay!
the type checking only is, I can totally see that in our pipelines where we normally run the build just to make sure that the type checking works, and actually don't want to have the build compilation at all.
Yeah, actually, code generation is fairly expensive in the TypeScript compilations that we do. So if you don't need output from a build, being able to say just type check it and don't actually generate anything is really valuable.
I do love these flags. And I also want to say, and I hate to say this because I don't ever want this party to end, because this is like the ultimate nerd party. It's like being in a conference again. I love this conversation. But I just want to remind Igor that you have a hard stop at the top of the hour, my friend. So we have like 30 minutes left. And I think we're still on RFC 2 of 3. So I just wanted to and you can totally talk about whatever you want. I just wanted to just give you a quick reminder. High level.
We should still meditate.
I totally, I never thought anything about meditating at all, ever. And then you came up with it out of left field at a conference. I was like, why are we meditating? Like, we're sitting here, like 500 people or 1,000 people in the room meditating with Igor Minar. And I was like, what is going on here? But I got it. But it was kind of nice, you guys. It was like, hey, this is actually really relaxing. And I didn't really pick up on it at that time, and I wasn't ready for that in my life yet, but it's been years since then, and I actually would say that it has become a very important part of my life, meditating, and I never would have even gone in that direction without, and I didn't go in that direction that day, but it was just like putting the bug in my ear that it came back, and so I totally would be fine with having a meditation session at the end of this. I support you, Igor, and they're not going to argue with us if we're both telling them this is what we're going to do. And even Martin is, look, see, we got support from Martin. So, okay, so we're going to save time. We're just going to do it, you guys. We're going to save time at the end for a quick meditation session. And I know this might sound crazy. It sounded crazy to me too, but I want you guys to join us because it's just, trust me. Yes, guided. Igor, is that okay? Igor will do this with us.
I don't want to force this on anybody. So
I will. Don't worry. You don't have to force anything. I'll tell them. They'll listen to me. I'm like their mother. But we have time at the end, so we'll just save time at the end for that. And we'll.
Have you met my mother?
I've met your wife.
Okay. I will introduce you to my mother next time. So she will tell you how good I listen to her. So.
Yeah.
You know what? Yeah, I actually proposed that we take like 2 minutes break. I need to refill my water bottle, and we've been just talking for an hour and a half. So let's just take a 2-minute break and continue in 2 minutes. Would that work?
Yep.
Okay.
Yes.
Cool.
Yes,
I turned my camera off and had a snack while you guys were talking, so I'm cool. And we had a couple new people join in. I posted the link to the Google Meet in our Angular Nation all member chat. And so we had just people like random, because Mitro, are you still here? Where's Mitro? He's not. He was here. Okay.
Are you by any chance trying to say Dmitry?
No, I know who you are.
Okay.
I can't call you Mr. Anaboka, but I will never forget you because I'm friends with your wife and she adores you and speaks very highly of you. So I already like you. But no, I'm talking about Mitro. I'm just for today, I'm going to say more famous than Igor, which is amazing because I think Igor's famous. But yeah, We had a lot of people come in from Mitro's YouTube channel, so I think we're gonna have a hangout with Mitro, so that, because I'm sure there's a lot of people that have been watching him on YouTube for a while that actually have not met him. So that'll be something fun too.
Hey Craig, how are you doing? We're having our break, so we can chat.
Yes, we can.
I'm good.
How was your talk?
Good.
It was so cool.
Fun.
It was a good talk.
Yeah.
It was very fun.
I realized I missed a thing that I needed, so I updated it, which is good. Good feedback at the end, all the usual things.
Are you currently on the other side of the planet, or back
Nope.
in Europe?
Back in Europe, this is my Sweden apartment.
This is so much fun, you guys. By the way, we're going to do more sessions like this. Alan is coming tomorrow, and he has an RFC, and I don't remember exactly what the RFC is about. Oh, it's about cache. Where is it? And then, okay, the new persistent build cache. It's an experimental feature that he's thinking about making default. And I don't know if you guys remember, I don't know how many of you are here now that were there, but we had a conversation, and I know Sonder was there, it might have been in one of our Friday socials where we were talking about the roadmap, and everybody said, because I was looking at something that was on the roadmap, and I think it was the persistent build cache, and I was saying, hey, we're going to have Alan come and do this. We looked at the Angular roadmap, and everybody got excited about the what was it, Sonder, that everybody said, go get somebody from the Angular team to talk about this? It was the NGC STSC, huh?
Optional modules.
No, well, yes, we had that conversation, but also it was the NGC as a TSC plugin was the one that everybody said, we want to talk about this. Go find us somebody who's working on that. And so I went to Minko, and it took him a while to answer me because he was traveling. But he did answer me, and guess who it was that we wanted to talk to, y'all? It was Alex Rickabaugh.
Hello.
I was like, I love Alex Rickabaugh. Okay, yeah. So Alex Rickabaugh, the community specifically requested that we have a nerd session about that. And also we're going to have Minko coming to talk to us about the front end, micro front ends, which everybody is really excited about. And we definitely we had such a good turnout for that. And Minko and I got our wires crossed. So we're going to have more sessions coming up with the Angular team. This is not just today. We're just getting started, you guys. It's just, the party's just starting. Love it. I'm so excited about this.
By the way, while we are just randomly checking, Alex, do you think that the imperative view might also be, the syntax might also be a segue to getting better Angular elements?
That's an interesting question. I think they're probably unrelated in the sense that you could probably, if we had an imperative template API where you could create something that looked like a component out of like a dynamically constructed template, then I don't see a reason why you couldn't make it an Angular element as well. Just pass it to create custom element and have Angular render it in the normal way. Because once you get that, kind of dynamic component, it should just work like any other Angular component. What aspect of NG elements were you hoping this might improve?
Actually, I hope that the size of Angular elements would be improved by that. So this
the like runtime code size?
Yeah.
Yeah.
But I don't, like you described it, I think it wouldn't.
Yeah, I don't think so, because it wouldn't have much impact on how the like code shape of what an element looks like at runtime. It actually would probably make it worse, because you would end up with
it was just like, because Igor mentioned Deno or Dino, how I learned it's now pronounced. And there you can use, for example, import maps. And something in my mind thought about, okay, if I take all the human readable Ivy stuff and compile it in an in-between step and then change via import maps what actually code is used, maybe I can use something that is lightweighter than the Angular to just render Angular web components out of Angular elements. Just random. Yeah.
So I think that the biggest opportunity to improve code size for web components is to share the Angular runtime across all of the different web components that you're using, all the different Angular custom elements. One of the challenges today is if you want to package these things for individual reuse, then each of them has to ship, the entire Angular runtime, or at least the subset of it that, the instructions that custom element uses.
Yeah, and
it's better if you have several different versions of Angular as well.
Just of course.
Oh, yeah, sure, yeah.
Yeah,
like
and
we to have more than one kid, right?
Yeah.
We don't have a great way of configuring a bundle today where you can say I want to ship a bunch of these things and the Angular and the one copy of the Angular runtime. And I think this is where the like module federation micro front ends work might actually have some overlap there, because a lot of that is concerned with like how do we share dependencies across things that are individually deployed.
And I think this is I really think the whole micro front end, like, it's going to be a whole conversation in itself, and I'm very excited about it because so many people are interested in this. But I also want to circle back to Igor because he went to get a drink of water and then we just kept right on talking. And we have about 20 minutes left. So Igor, how do you feel? Did you get the answers? You have more? Is there anything else that you really want to cover that we haven't covered yet?
The thing that I feel good about, but also uncomfortable about, is that we have not surfaced anything that hasn't been discussed yet in the RFC. So I don't know if it just means that we're covering all the bases, or that we're still not getting all the feedback we need. Because I would love it if we like broke this in some way and said, no, this cannot be done because this, and then we would be like, oh, wait a minute, we need to think about that. So
I think it takes people a bit to get used to
yes.
each other. I know on Angular Nation, it took us a while to get everybody to like turn their cameras on and start joining the conversation. So I think having more conversations like this going forward will kind of help people start to get more comfortable. But I also think because you and I talked about this and then we put it on and then we just like did it pretty quick. And so probably we might get more feedback as well if we post the recording. Yeah. Because I think some people just aren't quite comfortable like jumping into the conversation, and to see like the whole discussion, I think really helps a lot. So I think we hopefully will get more as we go along.
Yeah.
But I think it's a really good, it's an interesting conversation.
I just want to encourage people to like point out flaws or break this, because now is the time to do it. It's still cheap to do it. Once we start thinking about this kind of stuff more seriously and invest enough more effort into it, and that's when we discover like, oh, actually, whatever, we missed something big, and you knew it now. You would do us a huge favor if you would share that with us now. So don't feel like you cannot contribute or you don't know enough about this. Like, just point out flaws or things that don't make sense to you, because that can start a conversation about something that we might have missed. And we're in this discovery phase where we want to uncover as much as we can before we put too much effort into this stuff.
Yeah, I really have been thinking about use cases and things that would break. I didn't come up with one just yet, but if I find one, I will let you know. But I think more people should do that.
Sounds great.
I also think that due to maybe the experiences that we have had, maybe we haven't hit the right theme, I guess, of your RFC. So maybe that's another issue that.
Yep. Yeah. The things that did come up in RFC that I didn't initially think about, and I am very grateful for, is Storybook and Jest integration relying on JIT. I was not aware of that, and it was great that that showed up, because now it's something that we need to address up front, and we have the people that we can work with. Hi, Kai. To address these things so that the community has a good time if we do make these kind of changes.
Maybe from a more organizational point of view, I like this format because just by accident, I just realized those 4 topics again. I stopped scanning the issue tracker every day. And sometimes it's really hard to surface those discussions. And for example, I just realized about it yesterday. I sent those 4 issues into my company and looking forward to get feedback from them. And I with hundreds of teams on I don't know how many Angular projects, I hope that there will be some feedback at least. So the surfacing of those RFCs is something that needs to improve, for example, with that to get a broader feedback.
Yeah. So with this one, I think this RFC is taking a little longer to get more traction because we haven't tweeted it or pushed it out on Twitter last week when I published it, intentionally, because we had another RFC already going out. So we had persistent build cache going on, and we didn't want to mess with the DevRel push for that one. So I did publish the RFC last week, and only this week we're actually doing the DevRel push for this RFC. It started yesterday, so our amazing DevRel folks are out there trying to make the community aware of these RFCs. But I expected somebody like Sander that, you know, they would pick up on these things as they come out.
Wasn't he the first one to comment?
He's always the first one to comment.
Not always.
Well, I love this format, and I think this and obviously, I mean, I love the Angular team, and I love all of you. So we're definitely going to do more conversations like this going forward. We have Alan coming tomorrow, and like I said, I'm already talking to Alex and Minko. So we're definitely going to be getting more, and hopefully this will get more traction too, because I think it's so much easier just to discuss these things face to face and ask questions and kind of kick things back and forth than to put it on GitHub.
Right.
So we will do more of these for sure.
Okay. So
I've got a question which is possibly a bit cheeky, but I'm just wondering, like, what's the relationship between the GitHub RFC and your internal process at Google? Like, I'm assuming that there's, you know, that's where the Angular apps are. Are they engaging in the public one, or do you have an internal way to handle?
So this RFC is specific in that it doesn't really affect internal usage of Angular at Google. Aside from the unit testing use case, JIT is not used at Google at all. So if we can make a decision here without bothering the internal Google developers, I don't know if we had, so when it comes to the out-of-band type checking, I actually did send it out to some of the internal teams, so they also aware of this. Other RFCs, we're trying to, we have internal community meetings as well where we discuss these kind of RFCs, but we encourage Googlers to also weigh in on GitHub and just be part of the community. So many of the people commenting on issues are Googlers. It's just not obvious from the comment. Cool. Can we go back to the last proposal?
Yes.
Awesome. So this proposal came out of the discussion around how can we make the builds, Angular builds, faster, especially when focusing on the edit refresh cycle, the local development workflows, interactive workflows. And one of the options that I proposed as an implementation option in the out-of-bound type checking was that we could significantly speed up the generation of JavaScript and also code necessary for type checking if we parallelize the compilation more than what we do today. And if you look at Angular today, the unit of compilation that Angular compiler can process at a time is something that is called TypeScript program or TS program. It's a unit of code or set of files that are governed by a single TS config. So you have TS config. In the TS config, you have this files property, which is an array of files, or you have includes and excludes, and that just creates this pile of files, and that's the unit that Angular compiler also uses as a unit of compilation. Now, these compilation units are relatively big. Small Angular applications have just one compilation unit, which means the compiler has no option to parallelize anything. This is the whole world that it needs to compile. At Google, we typically have each directory be its own compilation unit. So that is very fine-grained. And typically you have just like one or two components in a compilation unit. You can use that model if you're willing to use a build system that knows how to stitch all of these fine-grained dependencies together and parallelize their compilation. We use Bazel for this, or Bazel externally, Blaze internally, and it's not something that everybody can use, but more and more bigger companies are starting to switch over to Bazel just because of the benefits of this parallelization and other benefits that Bazel has. But even Bazel has this problem where if the compilation unit is it defines several files, and we have some directories that have many files, it's not possible for us to compile individual components in parallel. In CLI, it's even worse. You typically compile the whole application. Alex, do you want to?
Oh, I was just going to chime in. Like, in addition, even if you have a very small compilation unit, we still need to look at all of the dependencies of that compilation unit, and you still end up with these, like, the program is actually still massive, even if it only has two TypeScript files.
Right. So this is one way of doing things, like using the TS program as a way to compile things. The other extreme is pure syntactic transpilation, and this is what ESBuild and Babel and many other things do with TypeScript, where they basically just syntactically strip all of the types and turn into JavaScript. There are also templating systems that work in a similar way, where the template can be just syntactically transpiled from the declarative syntax to JavaScript. And this is ideal for some use cases because it allows you to just fully parallelize the build. You can just read one file in isolation from all the other files and do purely syntactic transformation on it to produce a JavaScript file. This is something that Angular in its current form cannot do. And we cannot do this because we have features like selector matching, and we have like these additional layers of indirection and features that Angular has that would prevent us from employing purely syntactic transpilation. However, between these two extremes, purely syntactic transpilation and whole program compilation, there is this middle ground. And the middle ground is finding smaller clusters of files that can be compiled independently and could be processed in a way that is fully backwards compatible and doesn't make trade-offs with regards to either compilation time or any kind of like AOT optimizations that we would not be able to do, or type checking that we would not be able to do. And this is the whole idea of localized compilation. So with localized compilation, the essential idea is that the unit of compilation is a file and any of its direct dependencies. And let's see. Okay. I'll just leave this on the screen. So it's a unit. So imagine that we would be able to look at a single Angular component and try to compile it without trying to compile the whole world. The way that would work is the compiler would have to understand where is the template. So it would have to fetch additional file if it's an external template. It would have to fetch the style sheet, which is probably external template. And it would need to understand at least the selector matching for all of the components used in the template of this component. So we would have to have some kind of understanding of the metadata of components that are used in the template. But this is still just a small portion of the whole world compared to just compiling the whole application as one chunk. And what's better is that you could have several components that are being compiled in parallel using concurrent processes or threads or some other parallelization mechanism. We would still need to do some coordination because some of the metadata and dependencies are shared between these components, and Alex has lots of ideas about how this can be done. But the end benefit is that instead of having this one big compilation that can take dozens of seconds, we could actually split up into many different compilations that run in parallel and could finish in a fraction of the time. This model would be much more compatible with how ESBuild or SWC or Vite works. And we would be able to take advantage of that parallelization that the systems employ. And additionally, specifically with Vite, one of the options that we would have on the table is to lazy compile things as they are needed. So we would be able, as you go in the dev server and navigate to a particular route, just like Vue does with Vite, and lazy compiles only the components that are necessary for rendering that route, with this localized compilation, we would have the same option. And we would be able to just compile only part of the program that is necessary for the dev server. So this brings up like a whole new mental model of how the compilation works, and then brings up new opportunities for better development experience. It's not something that is like trivial to implement. Like this is a significant amount of work because it's a big departure from where we are. And there are a few prerequisites for getting here. One of them is we would need to do the out-of-bound type checking, because if you have type checking in the way that you lost already. The second thing is ng modules and moving to like module-less world. This is Alex already did a presentation at Angular Nation about standalone components. So this is a project we are already working on, and it's kind of aligned with this kind of thinking. So if this project goes well, we would be unblocked on this. And there are a few other things that we would need to sort out before we could use something like this. But the potential benefits are just ginormous compared to like micro optimizations of the compiler that we can keep on doing, but there's diminishing returns on that investment. And I'll turn it over to you because we're going to run out of time. Alex, would you like to contribute anything else?
I just find this particular direction really exciting. I'll say this is a personal opinion. It's not like an official stance or anything, but I generally feel like the fact that most JavaScript tooling is written in JavaScript actually causes a lot of performance problems in the ecosystem that we shouldn't have to deal with. And so that's why you see this new generation of tools that are being written like ESBuild or SWC that are achieving pretty huge speed ups by kind of taking advantages of some faster runtimes and languages. And I'd like to experiment with how we can fit into that ecosystem. Another thing that I'm really excited about is WebAssembly. And Igor talked earlier about running the AOT compiler in like something like a service worker. If you are in these ecosystems with Go or Rust or some of these newer technologies, there are routes to compile that code into WebAssembly where it can be loaded in a browser and run as part of something like a dynamic UI drag and drop generator. So there's lots of opportunity there, and it gets me excited.
I'm excited too. I'm excited that you guys are. I'm just excited that all of you are here. This was so cool, and I don't ever want this call to end, but I am going to stop it here because Igor has a hard stop in like 3 minutes, and so we just have to call it because I don't want Igor to be late for his. He's a very considerate person, and he would never be late. So I have a little tradition that I actually have. It's real. This is my favorite part of the call because at the end of every call, I want all of you to come off mute and thank our guests. And it's just so much fun.
Thank you.
Thank you, Igor.
Thank you, Igor.
Thanks, Igor.
Thank you, guys. Thank you, Igor. Thank you all.
Thank you. The pleasure is mine.
Hope you found what you were looking for.
Yeah.
All right, I'm going to stop the recording. We're going to do this again soon and often, so watch your notifications, and we'll see y'all soon. Thank you again, Igor and Alex and Sonder. And,
Thank you, Bonnie.
and Kai and Martin and everybody. You guys are awesome. We'll see y'all soon.
Thank you
Bye.
very much.
Thank you all.
Thanks, everyone.
Bye-bye.
And
Bye-bye.
if you have any thoughts on this, go to the RFC. Feel free to comment.
Yeah.
We're happy to engage more.
Yep.
Absolutely.
Thanks, Alex.
Thanks.